show, and thanks so much again for joining us.
Yep. Thank you again for hosting me.
Can you tell us where are you streaming from right now? I usually like to ask people, and I guess my dog has decided to start squeaking her toy, but you'll be hearing pets in the background. But don't worry, once I'm off, you won't hear anything.
Yeah, so hey guys, I'm Amanjeet Singh and I'm from India, capital New Delhi. And I work at mobile.dev as a senior software engineer, where our mission is to catch all mobile app issues pre-production, whether it is your iOS app or Android app, or you are working on any React Native cross-platform framework. So mobile.dev is there to catch all pre-production issues. And most of my experience has been into solving for platform issues, which mostly revolves around scalability, stability. So one of the example is native crashes, which we are going to talk about today, and it is going to be interesting to all of you to see how we tackled around native crashes in one of my previous organizations. So yeah, that's my background, and
Ooh,
happy to be
love
here.
it. A hot and spicy topic. I can't wait. I think there's a lot of it's always exciting when we get to kind of see real use cases, especially when it's kind of applied, across the career. So that'll be really exciting. Yeah, yeah, and for anyone who might be watching, feel free to let us know where you're watching from. And I guess other than that, we'll just run through some quick logistics. And after that, I'll have you back on and we'll hand the floor over to you. Okay. Yeah, so for those watching, welcome to the Chicago Kotlin user group. A little confused because it's oh, there's no viewers, but I do see some people commenting, so maybe it's not quite right on the count. Yeah, this is the first Kotlin user group of the year. So whether this is your first time or you're returning, welcome back. I'm kind of excited because, it's been 3 years since pandemic, and I guess we've been online for a while. Now we're going a bit more hybrid. So that's kind of an exciting combination. Yeah, if you've never been to a Chicago Kotlin user group meetup, we believe in being inclusive. CCUG is an inclusive and accessible group. Oh, yes, now that we're doing in-person events, we'll be asking folks to mask up. I don't think it's worth catching COVID for a tech talk. In any case, always be curious, ask questions, and avoid assumptions. And we should be doing everything in our power to continue to grow trust, empathy, and friendship. Oh, yes, we do have CFPs open. I am not 100% sure if the description has the most updated link, but I can be sure to comment in the comment section after for the guaranteed link for Google Forms for this year. We are looking for new speakers. We're looking for experienced speakers. They've all been great. I don't think we've turned anyone down. So yes, please definitely give us original content. And we do have online options and in-person options too. We'll be starting up other places in the city. So that's going to be really, really exciting. Super. It always looks great on a resume. And usually a lot of these talks, they might as well be submitted in other places. So please use us. It's just a super chill space. Yeah. Okay, there are a couple ways to keep connected online. We do have the Kotlin Slack, and we're on the hashtag Chicago channel. And we are now on Mastodon. You can find us at Chicago Cog at fuj.social. Ooh, one more thing. We do have kind of a fun YouTube channel and a list of meetups from the past few years. You can view our talks here, including this one. I think that's everything for my ends. I'll just go ahead and bring it up here. And yeah, thanks so much again. And yeah, hopefully how are you feeling about the talk and all that? Are you feeling ready?
Yep, I am ready,
Okay.
definitely.
All right, sounds good. Oh, and just to double check if people have questions, like they can put it in the chat. So feel free to ask questions during, and um, I'm not sure, like it's your preference whether you'd like to answer the questions like as you're looking at it or just look at it at the end. So whatever works. But yeah, I'll go ahead and give the floor over to you. Do you have your screen shared? Because I'll need that for that to go up.
Uh, just a minute, I am actually arranging my displays.
Okay, no
Um,
problem.
mhm.
So, is this like in terms of pandemic? How many in-person talks like have you like attended versus like online talks? Just out of curiosity.
uh, like speaking out of my speaker experience, this is going to be my first remote talk, I would say. I
Well,
am.
how does I'm sure it feels a little weird because there's you can't like see other people. I mean, they can see you.
Yeah. That's why I am a
Yeah,
little
it's hard
bit.
to get a read. But I assure you, like the rest of us are sitting on the other side, just like same vibes. So
Yeah, but I actually definitely like the more networking part. I miss networking when there was full pandemic. So
yeah,
I think that part, the physical
that's really what
conferences
we're there
and the
for. No, we're there
yeah
for the talk too. But yeah, it's hard to do these meetups like without that socializing aspect. We only have this chat. We make do. But I guess the other nice thing too is to be able to give talks like in other places like without as much of a commitment. So, there's pros and cons. How's the
yeah
display thing going?
yeah, it is ready, and now I am ready to share my
Okay,
screen. Uh,
great.
Share screen, and just going to confirm, is my presentation visible?
There it is.
Oh, okay, awesome. So we are good to go, right? Uh, okay,
Um, okay, looks okay to me. I'm gonna just show myself out and give the floor to you.
okay. So yeah, hey folks,
Okay.
I am Amanjeet Singh, and today we are going to see how in my one of my previous organizations we tackled with native crashes, and it is a case study walkthrough. I'm going to tell you like story how our organization reacted when we had native crashes all over our Firebase console, what the environment was like, and how we were in a situation to tackle all those things in our platform team. So let's first look at our agenda for today and see what we are going to cover. So yeah, first of all, I'm going to tell you about the experience of having native crashes in your Firebase console. If you have native crashes in your Firebase console, this would be very understandable to you guys and would be very curious for you guys to see that how a organization reacts to native crashes. Then I'm going to cover the POCs that our team did to root cause those native crashes. And the next step would be to cover the root cause parts and the POCs that we did for having those signal aborts, which was one of the major contribution on the native crashes, to see that why there were signal aborts and why was that the major distribution in our native crashes. And then how we actually created an observability from production on native crashes. So this journey really begins from having this libc.so crash, which is a indicator that you have a native crash on your Firebase console. and we didn't really have any useful information that we have in a JVM crash. Like if you see and think about a JVM crash, you have a stack frame information. You know where this Java crash is coming from or the Kotlin crash is coming from. You have line number and all of those information. But for us, it was like everything is missing and everything was under this libc.so umbrella, and the volumes were increasing. It was like for first few versions we were just ignoring it, but now there was a point in our life where we can't ignore it anymore. And one of the developers, which like I have stated it as Bob, but it is really me. So he noticed that there are different native crash signals. It was signal abort, it was segmentation fault, it was signal bus. There were other native crash signals as well, but we only knew them when we were navigating across the libc.so crashes because it was all under this one entry. And this was actually the problem number one for the platform team because they didn't knew that how much distribution of signal aborts there are, how much segmentation faults there are. So they can't really prioritize one report. They can't really say that, okay, we will start solving from signal aborts or we will start solving from segmentation fault. There is no really like a pie chart which we can just see and have that information in one go. So since there is no stack frame information also like we have in the JVM crash, everything was like we can't solve it immediately. We can't have answers immediately. And after this, because this information was nowhere available, so the aftermath of this situation was that product team was not happy. They were asking us timelines, and we didn't really have any answer. So we decided that we will actually create a objective like OKR around it, and we will solve it like a very formally by creating a OKR around it in the next quarter. But this was also very challenging because for a problem which is very indeterministic, you can't really commit a very deterministic period of time. You can't say that, okay, like my team will be going to solve this problem in like 4 weeks. But since we didn't have any observability, we just like asked for a buffer of time, which was like, let's say 7 weeks or 4 weeks. And this is one of the things which I have also noticed, like most of the platform teams doing. But believe me, this really doesn't work. And especially for the problems which are very difficult to root cause. And yeah, this basically led to a frustrated environment. Everyone was frustrated because when you commit a very high hit and trial type of time to the product team, they don't feel like very confident on the team that, okay, are you really going to solve the problems in the X weeks that you have asked for? So this developer Bob, he started doing some like POCs, noticing patterns in the crash reports that Firebase already reported. So one of the things that he noticed was that this signal abort, it is one of the major native crash signal that the Firebase had because, and this was like a manual observation that he did because he was just navigating around Firebase console and he was noticing that every other crash that Firebase had, it was signal abort. And another interesting find was that at every instance of this signal abort, the device memory, which is the system RAM, system device RAM, it was less. And it was only with the signal abort. Like in case of signal bus, it was not really the case. Most of the signal aborts are combined with the system RAM, which is like low. So the question that he next asked was like, what is, and like when this native crash happens, like what is the life cycle of native crashes anyways? So for that, I'm going to just brush up like how JVM crash life cycle looks like. So it starts from Java and Kotlin, and then the control basically passed to the Firebase crash handler. If you have installed any SDK which performs your logging to any console, like for example, Instabug or Firebase or Bugsnag, they have their custom crash handlers installed in their code, which they mostly do it at cold start. And then after logging their information, this basically pass control to the uncaught exception handler, which is the native handler of the system. And this basically then passes all the information to the logcat, where you see the stack, do the root causing, and it then exits the app and terminates it because there is a crash. Now, for native crashes, this really starts with a C++ code, and there is a custom native signal handler, which basically from the code level, it iterates through all the signals that you want to catch. And then there is something called as sig action, which is a system call, a system kernel call, native call, which installs the native crash handler. And there is a function pointer, which is basically like a callback, which says that on this signal abort, this function is going to be called, and you can do your things there. For example, logging or whatever the custom SDK like Bugsnag wants to do. And then the control will pass to the default handler, which is basically responsible for dumping the tombstone and the useful information on the logcat, and then the app will exit. So this is a sample of a tombstone, and this is like not the whole tombstone file. This is really like just the header, which will tell you like information like which app it is coming from and which native crash the tombstone was generated with. And for example, this is signal abort, so it is going to tell you about signal abort and what is the reason of the abort message, what is the reason of the signal abort. So for example, in this, I have just called abort, like just the function abort, and it was the thread was basically aborted. And there will be the stack pointer addresses and the stack of each and every thread at the point of the time when the crash happened. And then the app will terminate as soon as the tombstone dump and logcat dump is completed. Now we have seen that how the life cycle of this native crashes is. The next part was for the Bob and his team to root cause this and do POCs around signal abort, because signal abort was one of the major contributor to the native crashes. So one of the things that the team wanted to first find out was to see that what is the memory relation with this signal abort. Because if you remember, uh, we just discussed about the system RAM being low at the instances of signal abort, right? So what was the reason for the system RAM to be low, and what is exactly this memory relation? So first, the team wanted to know about the reasons of signal abort. Now, the first go through documentation, the Android developer documentation, it tells you that signal aborts happen whenever you call abort function. So abort, if you look at the documentation, abort is really like a system call, a native system call like sig action. And whenever it is called, uh, it is basically going to exit your process. So it is like the system has reached a state where things can't be proceeded anymore, and like you have to exit the process. So this was the problem number three, that the app didn't have any native code of its own. So it was really confusing that like why we still have those native crashes, and the team was still finding the answers and doing the POCs. So next thing was that switching out of the Android and mobile world, we have to really think from the native perspective and really think from C++ perspective, that what is really that memory relation. So if you look at from the native code perspective, whenever there is any heap corruption, like these are some of the instances where the abort is called. So whenever you try to do the allocations wherever the heap is already corrupted, there would be signal aborts throwing from the native code. Then from the instance, whenever you try to call malloc, when your heap is already overflowing, like it is already filled up, and you try to allocate object, then signal abort is called. And basically, it revolves around memory management being done like very poorly on the native code side. That is the perspective of having signal aborts from the native side. Now, to really establish a relationship between the mobile world and this signal abort, the first POC that the team did was to just simply call abort function and to really understand how the tombstone file looks like. So they just call like abort function directly from the native code through a JNI interface, and they saw like how uh, how the native signal handler they dump the tombstone and the logcat information. So it just basically tells you about that the signal name that is generated, the process ID that it is coming from, and the stack. Now, the POC2 was that try to allocate a very large array and see that if basically it throws a signal abort or not. But now the next question was that what is very large array? Like how can I define a very large array or a very large object? Now, the first assumption was to allocate a array which is beyond the size of this runtime dot get runtime free memory. So just to recall this, this function tells you about the free memory which is available at any time in your JVM. But allocating array beyond this limit, it the app will not crash. And the app, like why? Because this is JVM memory, and we are trying to find answer like what is very large for native code. So this is not the answer because this is the JVM free memory. So the next question is what is limit of native memory, like the heap which is responsible for management of the native memory. Now, actually, like short, the answer is there is no limit. And I'm going to tell you through this representation. So let's say this is a vending machine and this is your operating system and this is your app. And it is, and let we are discussing only native memory right now. We are not discussing JVM memory. So your app asked for 256 bytes. So your OS happily allotted that much memory to your process and all the memory pages that your app needed. Now it again asked for 256 byte. So OS said, no problem, I'll give you the pages that you require and you can have more 256 bytes of memory. But now when you do that continuously for n number of times, there will be a point in the lifetime of this allocation when the lower memory killer daemon will be very active because the process will become very greedy of like having the memory. Now this basically is a time when the process is very greedy of allocation and it will basically force the lower memory killer daemon to become very active, and this daemon is responsible to kill all the apps which don't have any priority. So it is going to just compromise your mobile device and it will start killing apps which are very lower in priority, and OS will still try hard to swap more memory pages and allocate that much memory blocks to you. But if it is not possible, it is going to generate that signal abort, and then your process will be going to exit. Now, to verify this assumption, the POC that this team did was that there was this tool called as stress app test. And this stress app test, it is a static library, a C static library, which you can generate for your device architecture. So you can generate it for your mobile device, ARM64, or whatever device architecture you are using, or for emulators. And I have also done it in this repository. If you guys want to do it like the POC on your own, I have generated it for emulators. I will pass on these links at the end of the talk, and I'm going to tweet about it also, so you can have a look. So the thing is that this static library, it is basically created to run a stress test to generate memory blocks and make your device more greedy for the memory. And how it looks like is it is like a simple command. which runs for like it is a executable which runs for 20 seconds. So this 20 seconds, and it will you can pass the total number of size that your memory test for the memory test that you want to run for. Like for example, this example is for 1000 MB, which is approximately like 1 GB. So you'd want to run for like 20 seconds for 1 GB of memory blocks, and it is going to run for this 20 seconds and make your device greedy for like this 1 GB of memory block. Now, uh, this the idea is to increase this like allocation for a process, increase the allocation size when you are running this stress app test. So for example, your app ID is like com example something something. So what you want to do is conduct this stress app test and also make this process greedy for memory and allocate continuous objects so that this process will exit with the signal abort. Now, how we will do it is that from this process, we will just control the number of objects that you want to allocate. So this can be done by, so in my sample app, what I have done is I have done it through the number of objects, controlling this number of objects through the broadcast. And I am basically running this in a while loop, like an infinite loop. And this basically will just allocate five number of objects continuously, which are very large number of size. And in parallel, we are also running the stress app test, which is basically allocating this 1 GB of RAM continuously through the span of 20 seconds. So what happens is whenever you will run this script, it is going to basically create your process as a very like mark your process as very greedy, and it is going to crash it with signal abort. I'm going to share an article on it which is basically a step by step mention of how this POC was done, and the GitHub repository also in case you want to run it locally, and you can verify that how this signal abort uh, like whenever you will run this script, you can see the signal about being dumped in the logcat. So moving on to the solutioning part, since we saw that whenever the device is under memory pressure and you are trying to allocate more memory, your process is trying to allocate more memory, there could be a point in your lifetime of your process that it could just go and ask for memory blocks and crash. Now, let's move to the solutioning. The problems that we saw in the beginning that were there was no grouping for native signals. We didn't knew where to start from. We didn't knew how to frame KRs. We were also very unsure where this abort is getting called from and how is device reaching that large memory pressure. Like why is so much memory pressure there in at the first place. Now, this basically forced us to create observability from production because at that point of time, there were no out of the box APIs which are going to help us from the production environment to root cause all of these failures. So we basically developed a feature. This feature helped us solving this first problem, which was grouping the native signals to know the actual distribution, that how much signal aborts there are, how much segmentation faults there are, and different kind of native signals that we had in production. So what we did was we capture these different signals and different attributes and log this to Firebase Analytics. So what information we captured with this native signal, with the signal name, like for example, you get a signal abort, we capture the signal name, the user ID, the total session time of the user, and log this in the Firebase Analytics. Now, this was basically done through a custom native signal handler, which we have written in our app in the native code through a JNI interfacing. And on as soon as this native signal handler call this callback, wherever it tells that this signal abort has happened, we just log those user attributes and log it in our Firebase analytics. Now, the next step was that as soon as you get this crash, at the next launch, we asked our users to capture the bug report, and this was basically done by the showing a dialog box, because we knew that the app has crashed at the last session and it has exited. So at the next session, we shared like a user preference, and we show like a dialog to our user to help us root causing all these failures, because they were reaching a limit that definitely they were compromising the user experience. So the idea was to really collaborate with our users and to have the bug reports from our production environment. Uh, Now, this was not done for every user. This was basically done for only the few users who are reachable by our operations team. And we had a really good relationship with those users, because there are always a bunch of users where you send your app and do the beta testing for the first few features. So these were those users, and we knew that data, like for which user ID the crashes are generated, because we were logging this information in from our custom native signal handler. So this dialogue was there at the next launch, and we were asking our users to give us the bug reports. Now, if you guys are familiar with this application exit info API, you might guys would be thinking that why not to have a bug report from that API, and like there is no need to ask your users to capture the bug report. You can simply use this API, and this basically hands over the input stream of the bug report, and you don't need this like dialogue and all this thing. But the problem for us was that this API is only available above API level 30, if I'm not wrong, Android 11. And most of our crashes were below this. So there was no way at that point of time, at least, where we were able to like get the bug report stream or like the tombstone stream, because if there is no way to get that tombstone, you can't really root cause the problems. So this dialogue was a way to get the tombstones and for us to be in a place where we would be able to root cause the problems. Now, as I said, that this feature of showing the dialogue was not switched on for every user. We were basically controlling this by the Firebase. We were controlling this by a remote config. We had a segmentation for the users who were reachable by the operations team, and we were controlling this with the Firebase real-time database and the user property, and turning this feature on for only certain number of user IDs, which we knew that our operation teams can collaborate with. Now, what was the result from this bug reports that were channeled us by the operations team? We had the tombstones, like only like I remember the first three tombstones were enough to just indicate the problem, which was basically producing like large number of native crashes, like and contributing to this signal abort. So we actually knew now from studying like this tombstone that where is this abort is calling, like it is called from. So the answer was that it is called somewhere when the glide is trying to allocate your bitmap, because the bitmap allocation is happening natively. And glide is somehow trying to allocate this bitmap and it is failing. Like it calls malloc and it basically fails. Like the system is not in a place to offer you those memory blocks, and it throws like a signal abort. So the first suspicion was on Glide version, because we have not upgraded Glide from like million of years. So we were in a situation that okay, like the first step should be to upgrade this Glide version, because all these libraries they are continuously fixing things and they are doing optimization. So there could be probability that they might have fixed something on memory management. They might have fixed like because all of these things are happening natively, right? So there could be a possibility that the memory management was poor in that version and they have fixed in the next version. So the first thing that we did, the immediate story that we worked on was to upgrade the Glide version. And it really did work out. The crashes were starting like lowering down, and we could really saw from our Firebase analytics that the thing that was immediately fixed was the signal abort. But now we have answer to these problems. We have like grouping because we have the data in our Firebase analytics. We know why why abort is called. You don't have native code, but you are interactive with the system code, which is native, which is like written in native, like the AOSP code, or you are interacting with some third-party library which can use native code. So we have the reason why aborts were getting called, but there are other two problems. Like how is device anyways reaching that much memory pressure? So for this app, which we were working for, so this app had very large user session time. Like this was basically like a music app. Like you can think of it as a music app because music app have very long user sessions. You listen to music for like you can listen to music for 6 7 hours. So there is always a app component which is running, which is very long running. So this was a very similar kind of a scenario. And if you don't do memory management properly, there could be a situation that your process could become very greedy and could reach a situation when it is asking for like so much memory, and yeah, hence the signal aborts can happen. So, and it is not only about the native memory management, it is also about the memory leaks which can happen on the JVM side, because JVM is also going to call the native code. Like for example, if you just consider like a JVM call of like system clock dot current time release, right? So it is also calling like native code. So you should not ignore the memory leaks or whatever memory management the JVM has. And since this was piling up from version of apps, like from the first version, the native crashes were not there very much. But after like 4 5 versions, since we developed like 5 to 10 features, the problem actually became like a huge issue. And we had that like native crashes also increasing. Now, moving on to the next problem, the experience that personally I had was that how to frame KRs for these type of issues. What we can really do is, rather than just committing like a high level in time, like okay, asking for like 6 to 7 weeks or 4 5 weeks, it is really confusing. So what you can do is you can really create KRs like covering all important metrics, because metrics is what is going to guide you for these issues. If you don't log a proper metric, you are going to be running on like a wrong path. So for example, if I am not going to chase memory, I am not going to solve this issue definitely. So this was like the first like KR that I am going to say. Then KR2 could be like attempting 70% accuracy on fixing the issue, because when you are starting to solve these type of issues, like the team is not in a very good place to just solve everything at like one go. There would be situations that you would attempt a fix and it might not work. So what you can really say is that I attempted like 7 fixes or 10 fixes, and 7 of them work for us. So you can say like, okay, 3 of them not worked, but 7 of them worked, because like to be frank, KRs basically track your productivity. So this can help you track your productivity. You can in next quarter you can target this as to be like 80%. You can just try to raise the bar for the team. And next KR could look like quality gates, like because it is important after you solve every issue to have a quality gate around it, because if you are not surfacing that information, that problem can pop up again. So the quality gates ideally could be the third KR for the team. And this is actually covering like very generically. This can be framed for any like platform issue, I would say. And I have also done it with app launch time or other issues. So yeah, that's my time for native crashes. Any questions? So we have you are on mute.
Yeah, it looks like we do have a question from Todd. Did you ever tie in the JVM garbage and Shendoa to crashes or heap issues or see correlations?
Sorry, I think your voice broke, but I'm reading that question. Did you ever try in JVM GC type crashes correlations? Uh, I I think I didn't understand the question. So this JVM type 2 crashes of or heap issues. Uh, did you ever tie? I think can so request to Todd. Can you like maybe reframe your question? I think I'll maybe not answer it like in a proper way. I don't understand the question, or maybe someone can help me with this question. Uh,
Um, yeah, I guess he's like wondering if the garbage collection type, I'm assuming garbage collection type to crashes.
yeah, so
Um,
these are the
oh,
different
they're like
garbage
the different
collection
kinds of,
strategies.
yeah, yeah.
Okay, so I'll try to answer it like from what I understand. I think you are saying that having different garbage collection strategies, were there any differences in the heap crashes? I have not like done the POCs on different garbage collection strategies like on those other GC environments also. So I am not very sure if there is any difference, but definitely one thing for sure is that like these type of heap corruptions, like for example, doing malloc when the system is not able to offer you those memory blocks, that is going to be same for like all the heap types, I would say. So, but yeah, other than that, I don't have any like other correlations that I might have noticed. And then is there a correlation? So, Todd, like, do I have answered the question?
Yeah, I think you did. Yeah, I'm so sorry. I'm just like also posting a link to the article that's relevant to your talk. Um, yeah, definitely feel free to click that. It is a solid article stressing memory on Android. That's the one that's correlated with your talk, right?
Yep.
But yeah, thanks for the talk. It was really, really good. Yeah, for folks that are online, please definitely, if you have questions open, definitely type them in the chat and we'll give voice to them. Yeah, no, I was really impressed with the talk. I really liked that you also included just general organizational strategy as well. Sometimes it can be kind of hard to, convince folks that something like those segment faults and are important. I got to tell you, I've seen quite a few of those in Firebase crashes, and we've just learned to ignore it. And yeah, it does kind of grow over time. It never really occurred to me that you could do something about it, but that's really, yeah, this was really insightful.
Yeah, I think for platform teams, especially like this organizational part is like very important because at the end of the day, solutioning is definitely one of the things that you would do. But like interacting with product, convincing them and asking them for timelines And you have to really also convince them that what business value your like solving your issue would be. So yeah, all of those skills are very necessary for a platform team. So and then only you would be able to ask for the time, right? So yeah, that definitely this is very important part, I would say. And no, like most of people don't talk about it, but I think it is very important.
Yeah, no, it definitely is kind of almost like well, sometimes a spoken expectation, but also implicit that, you have to be the one to um, convince your team that there is major business value in putting in some time to get some of these segment faults down and segment errors. Yeah.
Correct.
Oh my gosh,
Uh,
great talk. Yeah.
Yeah, so actually, the funny thing which I have seen in my organizations, which I have worked with, is I have worked with both platform team and feature teams. With feature teams, it is very easy to just translate into like a revenue. Like for example, if I have worked for add to cart feature, I can really very easily say that okay, add to cart feature which I developed, which my team developed, it translated into this much revenue, with this much $1 million. But when you work on a cold start, improving battery drain or things like that, you can't really say like I have saved $5 million. You have to really show that and translate into like that business value. So I think that is very important, and that's how you can buy the time and show value to the business and product team.
Excellent. Yeah, thank you. This was a super well-rounded talk, very focused. Yeah, so really, it was really solid. Thank you so much again. And yeah, there's going to be more meetups in the year. Please definitely start putting in submissions for the Google Forums. And if you put in something and you're like, oh, I haven't heard back yet, just find a way to ping me. Um, yeah, but yes, thank you so much again. And yeah, I guess have a good night and a good morning for those in the Chicago area, of course. Thank you again, Amanjeet.
Thank you, and feel free to reach me out in case you guys have any question or you guys are tackling with any platform issues. Like we can collaborate and see if we can get to a solution.
Yeah,
Thank you. Thank you for your time.
thank you. Yes, Amanjeet is an Android GDE, so you can definitely look him up and look up his other work as well. I'm sure I know like there's kind of a divide on Twitter and Mastodon, but I'm sure we'll all like kind of get organized at some point. Okay, take care, and everyone have a good morning and a good night. Take care. Well, until next time. See ya.